So very good evening to all. Myself RJ Abinesh. So in this video we are going to see about space communication and deep space networks. So we will get into detail about it. It is an exploration of innovative communication system essential for interstellar mission and data transfer in deep space network. So let's get into the video. So in first slide we taken that the crucial role of space communication, exploring its impact and space exploration. So first subheadings like importance of space communication, then we will see about the application, then the support, then about the support of space mission, then interplanetary exploitation, then telemetry and data transfer, then real-time control, how it is managing. So let's get into it. So in next slide we first see about the fundamentals of space communication. In fundamentals of space communication there are many types of space communication. One is transmission of signal, then from the ground station we can say transmit or receiving the signal. Then the transponder is nothing but a spacecraft relays signals back to earth, enhancing this communication. Then antenna technology, advanced antennas are necessary for effective communication over vast distance. Then UFS frequency band, this is also used to avoid used in short range communication from planet to planet like that, or space, or from area to area like that. We use the UHF frequency band. Then S-band frequency, S-band frequency is nothing but a voice and data communication for mission. Then X-band frequency, X-band frequency is used used in high data rate transmission. For higher specification it is used for X-band frequency. Then Ka band frequency, it is also a very high data. Compared to X-band frequency, Ka band frequency is very high data, essential for modern communication. Modern communication means advanced level communication, we can say that. So let's get into it. So let's understand about the space communication challenges. In space communication challenges, first main reason is long distance. Long distance like Earth to Mars, then Earth to Venus, Saturn, then Jupiter, like the long distance we used. Then signal delay and attenuation, how much signal delay it's occurred, then how much time taken to travel, then affecting the, then how much clarity we getting, and speed from transmitting the data from receiver and the sender. Then Doppler effects, movement of spacecraft can cause frequency changes in signals and complicating communication. Then power limitation, mainly space use the higher efficiency, more efficient power they use. So next, interfaces challenges, various source of interfaces can interfacing challenges like losing the signal or any disturbance or noise like that we came across it. So next we come down how NASA's deep space network overview. So how NASA see this, then NASA operated to the DSN network, which is, I say no, deep space network is operated by NASA, facilitating communication for space mission. It is also used by NASA to overview this deep space network. So then suppose interplanetary missions, then three main ground station. NASA usually locate their substations like Goldstone, then Madrid, Spain, then Canberra, Australia, like that. In that country, they located their deep space network. So next one. So next one, let's go about the overview of the DSN, which is Deep Space Network architecture and its components. So first of all, we see about the antenna types. In antenna types, the DSN utilize 70 meter and 34-meter antennas for optimal signal reception and transmission. Then coming to next one, high power transmission. High power transmission is most useful, which enables a powerful communication to the sent across vast distance. So next we see about the low noise receiver. Low noise receiver is essential for capturing faint signal like a small signal or distance space networks like that. We are using for this using the low noise receivers. Then data processing system. You all know that data processing system is used to handle and analyze the data from the space mission. So next one. So while understanding DSN communication, so first for understanding, first of all we know about the uplink communication. What is uplink communication? Uplink communication refers to the communication from Earth to spacecraft. From our Earth to in our space we have some kind of spacecraft. Now further communication using the uplink spacecraft, allowing commands and instructions set to be sent and received further up using the uplink communication. Then downlink communication. Downlink communication is a process where spacecraft send the data to the first one we see in the uplink communication is Earth to spacecraft, but in the downlink communication is space to Earth. Spacecraft to Earth. First uplink communication is nothing but a Earth to spacecraft, then spacecraft to Earth used for downlink. Uplink, downlink. So then the types of data. Not which types of data this include telemetry, scientific data, or any other coordinates like this is basis for crossing. Then any about the galaxies, then the solar system like that. The data they may pass through Earth. Then communication between them. Then high gain antennas. High gain antennas are employed for focus signal transmission, enhancing communication efficiency. So next one. So innovative technologies in deep space network. So innovating technologies like cryogenic receivers utilized for sensitive signals, enhancing data transfer for distance space machine. Then adaptive coding and modulation. Adaptive coding and modulation is by adjusting the parameters like coordinates or optimizing communication efficiency. Then high frequency amplifier. Most of the in video you can see the high frequency amplifier which is used to boost our signal for reliable communication over the vast distance. Used to boost our signal or used to amplification. So next one we see optical communication future trend, promising technology for high data rate transmission in space networks. So next one. So innovation in space communication technology, advancement in laser communication, then AI in autonomous communication, quantum communication, then inter-satellite communication. Advancement in laser communication was pronounced by the NASA LCRD showcase improved their data rates for communication. The AI which enhanced the decision making for autonomous, quantum exploring the quantum mechanics for in the space communication channel. Quantum mechanics exploring பண்றதுக்கு the space communication channel use பண்றாங்க. Then inter-satellite networks benefits, which deep space network benefits the interconnected satellite networks, which in the space there are many kind of satellites which are used to interconnect them. The next one. Then the importance of space communication. Importance of space communication come across that this is essential for exploring and scientific advancement in space, which is used to know about the what is happening apart from the planet and exploring from the other planets. Then is any asteroid is coming or not, then we can we need to helps to identify about that. Then deep space network significant acts as the backbone of the deep space mission globally for NASA and any other like Elon Musk SpaceX, which is made a backbone of it. Then future communication system. Future they aiming faster, smarter and more efficient system to enhance their space mission. So that's all. Thank you.